In this question, it is given that two rectangular blocks having identical dimensions can be arranged either in configuration 1 or in configuration 2 as shown in figure. One of the block has a thermal conductivity K and the other has a thermal conductivity 2K. The temperature difference between the end along the x-axis is same in both the configuration. It takes 9 seconds to transport a certain amount of heat energy from a hot end to cold end in configuration 1. The time to transport the same amount of heat in configuration 2 is. So we can just observe both the configurations. So we can easily identify that first configuration, it is in series. So if you are maintaining this end at a temperature, let's say that is equal to something like T1, and this end at a temperature, let's say that is equal to T2. So there is a flow of heat energy. So we can just observe that for this flow of heat energy, let's say dq by dt through it. So we can write the equation for that. Q by T is equal to nothing but difference in temperature delta T divided by the total resistance of this combination, equivalent resistance. So just try to understand what about the resistance of this combination. Let's say resistance of this conductor is nothing but R. So from the equation for resistance, thermal resistance, that is L divided by Ka, then the resistance of second one, we can write it as, let's say this is R1, then second one will be equal to L divided by 2Ka. So if I'm just taking this R1 is equal to R, then we can write this R2 is equal to L by Ka, we can take it as R, so this will be equal to R by 2. So the first situation is something like two resistors of resistance R and R by 2 are connected in series. So you can write the value of this equivalent resistance will be equal to R plus R by 2, which we can take it as something but 3R divided by 2. Now, so we can write the value of this time taken, that is T is equal to, from this equation you can write time is equal to nothing but the amount of heat energy into the value of equivalent resistance divided by difference in temperature. So over here in both the situations, we are transferring same amount of heat energy and same difference in temperature. So it's going to depends upon the value of this equivalent resistance. So you can write time is directly proportional to R equivalent resistance. So in the first situation, the value of equivalent resistance is equal to nothing but 3R by 2. And in second situation, you can observe that means in this situation or in configuration 2, these two blocks were connected in parallel. So in parallel combination, we know how to find out the value of equivalent resistance. We can write 1 divided by R equivalent in second case is equal to 1 divided by R plus, we can write this as its resistance is R by 2. So we can write 1 divided by R by 2. So this will be equal to 3 divided by R, or you can write the value of R equivalent in second situation is R divided by 3. Now from this equation, from this term, that is T is directly proportional to R equivalent. So from this relation T is directly proportional to R equivalent, we can write T2 divided by T1 time taken in second situation divided by time taken in first situation is equal to, we can take it as R equivalent in second situation divided by R equivalent in first situation. And R equivalent in second situation is R by 3 and R equivalent in first situation was 3R by 2. So you can write this as 3R divided by 2. So this R and this R get cancelled. So this is going to be 2 divided by 9. So you can write the value of T2 will be equal to 2 times of T1 divided by 9. And the value of T1 is given as 9. So it is 9 divided by 9. So 2 into 9 by 9. So we'll get the answer as equal to 2 seconds.